And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We are starting things out today looking at the Sun in 304 angstroms, an ionized UV emission spectra of helium. And we actually see some coronal mass ejecta here. We'll talk about it momentarily after we watch this 48-hour SDO video. And there's more coronal mass ejecta to come. Whether or not it'll be Earth-facing is for a different video to cover. There is a filament up here also, and we've got prime examples of how the Sun can be at very low states of activity and still produce coronal mass ejections. So here's what we're talking about. We covered this yesterday. You can see this area right here. We're expecting some more of this ejecta to be blasted out in this direction at some point today. You see there's a little bit there has already left, and this portion right here is going to have to make up its mind whether it's going to collapse back onto the chromosphere or be ejected out into space. So this is the view from stereo A. Here's the Sun in the middle, and the Earth is out in this direction. Let's look at some more data here. By the way, we are streaming live to Twitch because the platform is so good. Next, we're at HelioViewer. I'm going to show you the fields, and we don't see a lot of magnetic organization going on. Here's the fade to 304 angstroms. And we've got two HelioViewer movies that we've created today. One at the North Solar Polar Field area, just to see if we see any things like crown prominences in that coronal hole North Pole area, and we do not really see anything like that. That's 1 hour, by the way, 1 day of data. And here's the South Solar Polar region. And that poloidal field is currently in charge of the interplanetary magnetic field on which you live right now, the South Solar Polar Field. And we'll show you that in a moment. Next, the KP index has been pegged at 1 for the last about 2 full days. And here's a Himawari view of that annular solar eclipse that's all over the Science Wire today. And you can see a great GIF animation there of the way the moon overlaps the Sun, but not entirely, meaning it's not a total solar eclipse. And you can find all kinds of information about that on spaceweather.com. As well as check out the Bailey's beads. You see over here these little bright and dim spots. That's caused by lunar mountains and sunlight passing over and between them. 10.7 centimeter radial flux is at 68 solar flux units. Yet another indication that you can see the Sun doing stuff like producing coronal mass ejections without any sunspots and with very low levels of solar activity. Next, we'll look at the real-time solar wind. And we see some coronal hole magnetic connections here. There is a coronal hole. We'll show you it at the end of the video. Magnetic connection here, it looks like. Magnetic connection there, it looks like. And that's what happens when the photosphere is exposed due to what we call a coronal hole, where there is very, very slim amounts of plasma in between the photosphere and the Earth. Solar wind density, current phi angle at 283 degrees, solar wind density 3.56 protons per cubic centimeter, and solar wind speed very low, legit solar wind conditions, solar minimum conditions there, below 300 kilometers per second at only 297 kilometers per second. Very weak solar wind right now. GOES magnetometer is looking pretty smooth here, and we're expecting this to remain relatively smooth unless some activity suddenly pops up, which can happen with no warning. Here's the data from the Gong 2, the top view ecliptic plane field plot, and you can see the Earth is solidly in this large South Pole oriented current sheet here. And there may be some activity there rising around the region of stereo A. By the way, stereo B is out here, orbitally ahead of the Earth. So stereo B is orbitally ahead, but it sees older space weather. Stereo A is called stereo A ahead because it sees space weather first. Here's a line of sight field plot, and you won't see very much distortion of the B field here as a result of activity, because there isn't a lot of activity, especially in the Earth-facing zone. And for you new viewers, this is part of the National Sunspot Observatory. This is derived from 51 ground-based magnetometers, as well as one out on stereo A and one on stereo B. The data is 1 hour and 30 minutes old, and again, can change with absolutely no warning. Geospace magnetosphere movies are next, and you see a very weak magnetosphere with that extremely low solar wind speed. And you can see very large plasma spheres and very large Van Allen belts. We did get a little bit of an increase in the electron flux, we'll show you that, but still very low levels of electron flux regardless. And there's 4 hours of data, courtesy of University of Michigan Geospace Model V1.5. It's all based on the Space Weather Modeling Framework. If you want to read about it, just head to one of these pages, scroll down to the bottom, click Details, and you'll see a link to the Space Weather Modeling Framework, which will tell you all the variables used to derive the models. Next, we're looking at ground geospace magnetic perturbations here, coming a little closer to home. We see some perturbations over the Canadian geomagnetic North Pole, less so over the Siberian geomagnetic North Pole, and we also see evidence that the South Pole has crept into the southern Indian Ocean here off of the Antarctic continent during this geomagnetic excursion. Anyway, there's 4 hours of data. Geospace ground magnetic perturbations. Next, we're looking at electrons. And there are the relativistic electrons for the past year. Very low levels, and it's been pegged at these incredibly low levels with a very small range also, all the way back into April, around 420 actually. Next, looking at the GOES electron flux, to see we came up off the floor a little bit yesterday, slightly higher levels than we've been seeing, but generally cratered. And we could see this finally pop up now, especially with such a low solar wind velocity. Don't be surprised to see the electron flux rise a bit. Here's the total electron content, and this goes all the way out to the thermosphere, giving you an indication of how many electrons your GPS satellite must transmit and receive through. So very low levels there, very, very low levels there. Even around the equator at noontime. And I'll let that play through a second time here, looking for any anomalies. Some minor anomalies there over the Caribbean, as we've been seeing for the past 3 or 4 days. Next, looking at just the ionosphere layer. And this one's courtesy of Australian Government Bureau Meteorology. And the ionosphere is looking quite anomalous once again. Not as weakly charged up as it was yesterday, but big charge disparities happening there. Here's the latest image. That one is from, wait for it, 8 o'clock UT, and it's looking pretty normal there. Nothing to write home about. Next, let's see what's going on above my head, as the video was made at 4:09. Not to be confused with Formula 409, the cleaning product. By the way, don't toxify yourself with cleaning products. And if you're up before dawn, you may see Jupiter and Saturn and Mars. And if you get up before dawn, you might even see Venus rising before the sun. Here's where stuff is in the solar system. I like to use the planetstoday.com. It's a great visual. Just coming off of a new moon, which is my favorite phase of the moon. What's yours? Let us know in the comments. By the way, feel free to leave us a comment, and we appreciate all the interaction. We do read all of our comments, although we don't really have time to respond to them all. Here's where things will be in 1 week. As the Earth moves to swing past Jupiter and Saturn and Mars, Venus and Mercury are doing the same with Earth. Here's the largest quake of the past 24 hours. It's a 6.0 magnitude just off the coast of northern Iceland. Please leave us a comment if any of you Vikings out there felt that quake. Let's go down the list for the past 24 hours. So we see a bit of an uptick here, quite a few quakes of significant magnitude, including several 5s, like this 5.3 at Nicaragua, 5.4 at Micronesia, 5.1 at India. And those two were less than an hour apart. There's another one in the Kermadec Islands, north of New Zealand. Here's a deep quake at Vanuatu. It's 110 kilometers and a 4.6 magnitude. And we're just going to scroll up the list here. Small quake struck Tennessee. And again, that 6.0 magnitude quake came in at 1907 yesterday on 6/21, the first full day of summer. Some aftershocks striking there. Here's another deep quake at Vanuatu. It's a 4.6 magnitude at 203 kilometers. Second largest quake of the past 24 appears to be this 5.8 at India. Hopefully that one didn't cause too much damage, and adding insult to injury in the way India has been dealing with a, quote, pandemic, end quote. Last quake we'll report on over the past 24 would be this 4.5 coming in just a few hours ago here at Vanuatu. It's at 244 kilometers depth. So a couple deep quakes happening there at Vanuatu. Folks, if you're in an earthquake-prone zone, please have an earthquake plan. Plan to be an asset, not a liability in the event of a disaster. If you're wondering who the cavalry is, well, it might be because it's you. Next, looking at volcanoes, we see Mount Abico back on the list. Flight level 10,000 there. Semeru, flight level 14,000 there. Popocatépetl exploding. 20,000 foot ash plume there. Revenador exploding. Flight level 14,000 there. And as Sabancaya explodes, it produces sporadic puffs of volcanic ash and a plume to 25,000 feet, an indication today is not a good day to attempt to pole vault the caldera at Sabancaya. Next, looking at windy.com's pressure maps. Here's where pressure cells are now, and here's where we expect them to be at 12 o'clock. Actually, I'll let it play through. Again, windy.com, they've got a great mobile app. If you've never tried it out, perhaps install windy.com's mobile app on your mobile device. And here's where we expect things to be according to the GFS forecast at 1 p.m. my time. And for you new viewers, I'm located in Lehigh Valley, Pennsylvania, the eastern part near the Jersey border. Yes, the Jersey border is within bike riding distance. Next, looking at jet streams. There are the jets of the east. I would note extreme meridional jet stream flow here north of the Himalayas. You've got due south jet stream here and due north jet stream just a few hundred miles to its east. Extreme meridional jet stream flow, as opposed to zonal jet stream flow, where the jet stream goes like this. We see extreme meridional jet stream flow, which goes like this, traveling parallel to the prime meridian, and another prime example of it there. Doubled up, tripled up jet streams in the south. Going to be some very, very cold days down there in southern South America. And we've even got some jet stream blowing backwards here right off the coast of Cape Cod. You can see that jet stream there is moving east to west, which is utterly abnormal, especially when it's so far away from the equator. Next, looking at water vapor maps here for Africa and Europe. And there is a bunch of Saharan dust making its way across the Atlantic Ocean. It looks like it's been stalled a little bit there. And I meant that to be sped up to 16 FPS. There's the current situation. Next, looking at water vapor maps for the Far East and Oceania. How about lightning maps, where we see a lot of lightning striking the U.S. right now? Shout out to our Iowan viewers. Check it out. Edmond, Oklahoma is surrounded by lightning. And that's a stagnating situation. If you're in Edmond, you may have a heck of a light show. Hey, Dallas, there's thunder rolling in. Check out lightningmaps.org next time you hear thunder. Freak out your foes and impress your friends by forecasting thunder. Tell your Viking pals that you're a direct descendant of Thor or something like that, or perhaps Odin. Lots of lightning striking there. Let's look at the U.S. Doppler radar map. Very heavy storms there near the Texas-Oklahoma border, as well as in the Texan stovepipe. And Iowa continues to get pummeled. many, many strong storms yesterday. Shout out to David Schlatower. Here's the U.S. water vapor map to give you a better indication of what's really going on. And part of the reason why these storms are stagnating and moving so north to south is because the jet stream is going like this. And it's the cold air mixing with the hot, moist air that causes these strong storms, folks. It's caused by huge pressure gradients. Now, I've got a string of dry air above my head right now, so we're going to take a look at that, as we always pick different spots of the U.S. water vapor map to help teach people about atmospheric physics on the Daily Space Weather videos. And if you're wondering what's going to happen with your weather, do a search for NASA GOES interactive weather satellites. You'll find this page right here, and we're using the water vapor map. It's super good. And if you just simply understand that this air here is more massive than this air here, that will help you to understand how this stuff works. It's really not that complicated, folks. And we encourage everybody to impress your friends to know how to forecast weather. It's not that hard. It just requires a little bit of understanding of physics and hydrodynamics, perhaps. So anyway, that's what's going on above my head. And it looks like we're going to have some clear skies. Maybe I will try to get out and see Venus. I don't think I have a low enough horizon, but I may try anyway. The third brightest object in the sky, Venus. Have a look. Thanks to our patrons, the real source of funding for the content on the channel. Whether you're an associate or an assistant producer, we appreciate your continued support. Please encourage your friends to help our channel out and increase the probability that the videos will remain free and publicly visible in a timely fashion. We're also on Subscribestar. Thanks to our Subscribestars and to our one-time donors. We're also on PayPal, etc. Thanks to the Smash team for sharing the content, leaving comments, etc. Thanks everybody who left a comment. And we are all over social media. The links are below the videos. Also, thank you for flying American Smashways. Please keep your head and arms inside the Smash plane at all times, as we've got some bonus features. First of all, it's the 193 angstroms view. And we do see some coronal holes over here, rotating into the Earth-facing region. Those are probably the magnetic connections that we've been seeing on the phi angle. So when you see a 180-degree phi angle on the solar wind telemetry data, an indication that there's a magnetic connection forming. And don't be surprised if we see more ejecta popping off. Let's close things out with the standard issue intensitygram and the standard issue magnetogram. So here's the intensitygram, just to simply show you that there are no sunspots. Here's the colorized magnetogram. Places to watch would be here, especially, as perhaps there's some activity there, but not very much. And let's show one more 48-hour SDO video. It's the green one, 94 angstroms. And again, we do see a little bit of activity there rising in the northeast. Keep an eye on the Integrated Space Weather Analysis page to see what happens with the rest of that giant plasma plume that's kind of pointed out toward Earth. Will it collapse? Will it eject? Or will it stay put? In any case, thanks for watching. Welcome to the Neo Renaissance. Please visit the links below the channel. Please attempt to support the channel if you are ready, willing, and able to do so. We've got a lot of goals in 2020, and the year is young, so it's likely we'll accomplish all of them throughout the year, but we are well behind schedule. So remember, stare at the sun, don't drink, and if you do, don't drive, and since it'll never be now again, may that solar wind be at your back, and that covidiocy absent from your multiverse.